Robotics in farming and agriculture. After years of anticipation and raised expectations, robotics has finally begun to infiltrate the world of agriculture to make a difference in this critical industry. In its own right, the robot market has been growing for a while, with an expected market value of $23.67 billion by 2020. A startling $74 billion is expected by 2026, with agricultural robots accounting for a substantial portion of this increase. Applications for agricultural robots. Agricultural robots perform sluggish, repetitive, and boring chores for farmers, freeing them to focus on increasing overall output yields. Some of the most frequent agricultural robots are used for harvesting and picking, weed management, autonomous mowing, pruning and seeding, spraying and thinning, phenotyping, sorting and packing. Agriculture uses robotic technology in a variety of fields. A robotic is an automatic device that performs functions traditionally assigned to humans, or simply a machine that takes on the appearance of a human. It is a machine that observes the environment, processes the sensor data, and replies to it with computer instruction. They are artificial mechanical devices that can move independently but must be modeled, designed, sensed, actuated, and controlled by programming. It will carry out its work or functions without complaint at all hours of the day and night. Most robots include at least 5 components: sensors, effectors, actuators, controllers, and common effectors. Robots never weary, yet they are susceptible to malfunction if maintenance is not carried out correctly. Agricultural robotics is a logical extension of automation technology into biosystems, including agriculture, forestry, greenhouses, and horticulture. The way robotics play a significant part in pesticide application. The application of fungicides, herbicides, and insecticides is a common and important task in agriculture. It is common because diseases are common on plants, affecting plant productivity, and it is significant because it can have a substantial impact on crop yield and quality. Pesticides used in plant protection include fungicides, herbicides, and insecticides. Human intervention is currently used in pesticide application methods, whether mechanical or manual. Excessive pesticides are released into the environment and farmers' exposure to these harmful chemicals during the spraying process. In terms of safety, it protects the farmer from toxic substances. Furthermore, fewer pesticides equal healthier food items for consumers. Robotic technology is an alternative spraying method in agriculture that offers numerous advantages such as safety, sustainability, and environmental effect. Precision agriculture with aerial robots. One of the early applications of uncrewed aerial vehicles, UAVs, in precision agriculture was to monitor water stress in agricultural holdings. UAVs are now outfitted with thermal and hyperspectral cameras, as well as fluorescent sensors. An intriguing experiment is described in which the authors created a controlled shortage of irrigation to create a gradient of water stress in a citrus plantation. They compared the data collected by the microthermal and hyperspectral cameras mounted on a fixed-wing uncrewed aircraft to measurements taken on the leaves, thereby confirming the aerial methods.
For measuring water stress. Similar efforts demonstrate the feasibility and benefits of using airborne thermal photography to improve irrigation.
Weed control robotics. Mechanical or physical weed control methods, herbicide application, pre-emergence or post-emergence tillage, cultural management, and biological control are standard weed control methods. Although the technology for tractor-mounted real-time weed detection and management is not yet available, the notion of automated selective weed spraying in agricultural fields offers enormous potential for lowering economic and environmental expenses while maintaining a high degree of weed control. Various methods for weed detection, management, and spatial variable herbicide application studies have been presented during the last decade, and critically, a wide range of new precision agriculture technologies have been created and utilized in agricultural practices. Mesh-Eye's function in agricultural applications. It is a high-resolution smart camera with the ability to rotate continually in proportion to the range, size, and position of a moving target inside its field of view. Data image capture will then activate the color camera module, resulting in a high image resolution of the item. It has a radio transceiver, a thumb processor, an Agilent 2700 VGA camera module, and 256 kilobytes of flash memory. In agricultural applications, image processing can be utilized for the following purposes. We are detecting illnesses on the leaf, stem, and fruit. To determine the extent to which the disease has affected an area. Determine the shape of the impacted area. To ascertain the color of the affected area. Determining the size and form of fruits. Specialized robots for a variety of tasks. Traditional ground robots have various limitations due to wheeled and caterpillar mobility restrictions. Furthermore, the usage of aerial robots is not always practical, primarily when the activity must be conducted on the ground or indoors. Sphere robots are systems that move as a result of instability. These robots are utilized for various purposes and scenarios, including exploration and surveillance. The authors of RawSphere define it as a new low-cost spherical robot for detecting soil temperature and moisture in precision agriculture. Compared to wheeled robots of the same size and capabilities, the RawSphere is substantially lighter and more resilient in rough terrain.